Hello, welcome to Astronautic for Exploit. This is Dr. Ayonshola Ogundele. Cislunar space resonates for the next space exploration frontier. The focus points are as follows: Cislunar space and Cislunar space resonates. Cislunar space, the region surrounding the Earth and extending beyond the Moon's orbit, approximately 400,000 kilometers away, is presently receiving great attention based on its strategic position in the solar system. It includes the five Lagrangian points, which are stable in position with respect to the Earth and Moon. The Lagrange points, named after the astronomer Joseph-Louis Lagrange, are locations in interplanetary space where the gravitational pull of two celestial bodies, for example, the Earth and the Sun, balances the centripetal force needed for a smaller object to orbit steadily between them. Five of the unique Lagrange points, L1 to L5, are in the Sun and Earth-Moon system. The proximity of L1 and L2 are in line with the Moon, and the lack of atmospheric interference make them perfect and ideal locations and parking spots for satellites and telescopes. The L1 and L5, located at fixed positions of 60 degrees ahead and behind Earth plus Moon on its orbital path around the Sun, also make them ideal parking spots for satellites and telescopes. The stability of L1 to L5 zones enables spacecraft to stay put for long period of time with minimal propellant use for the station-keeping operations, or without the need for propellant for the adjustment of their orbital slots. Some of the rationales behind increased interest in cislunar space explorations are the benefits offered by satellites beyond low Earth orbit to the society, lack of Earth's deep gravity well to overcome to launch rockets, easy access of orbits beyond low Earth orbit, mining of space resources, easy region for developing space infrastructure, and a host of others. Earth's deep gravity well is one of the major factors limiting expansion of space activities. Beyond LEO mission, launched from the Earth consumes propellant. A microgravity environment provides an extraordinary laboratory where phenomena and physical processes can be observed without the distortion experienced on Earth. Lack of Earth deep gravity well in cislunar space helps scientists to understand the growth of proteins as near-perfect crystals, allowing them to decode the protein's role in Earth disease. Cislunar space. Cislunar space refers to the area surrounding Earth, extending up to the Moon's orbit. It includes various orbits, such as low Earth orbit, geostationary orbit, and the lunar orbital environment. Cislunar space is expected to become an important part of future space exploration, with plans for lunar bases, space stations, and asteroid mining operations. Operation of the Lunar Reconnaissance Orbital spacecraft around the Moon is shown in this picture. There are various cislunar space resonates, and they are satellites beyond LEO benefit society. Lack of Earth's deep gravity well, no launch vehicle constraints in space, easy access of orbits beyond low Earth orbit, cislunar space infrastructure, space resources mining, lunar exploration, and space infrastructure. Space satellite access in orbit beyond low Earth orbit are of great benefits to the humanity. Modern industrial life depends on satellites of various types and purposes, such as space access for global communications, Earth observations, weather monitoring, scientific exploration, and national security. Cislunar cargo transfer concept is shown in this picture. A single satellite in lunar orbit could provide periodic communication between the Earth and the far side of the moon. A constellation of lunar satellites could provide precise navigation across the surface of the moon, like the Global Navigation Satellite System and the Earth. A lunar constellation could provide constant communications or full lunar surveillance. Artist's illustration of Cislunar space station is shown in this picture. Lack of Earth's deep gravity well is another reason for having focus on Cislunar space exploration. Earth's deep gravity well is one of the major factors limiting expansion of space activities. Beyond LEO mission launch from the Earth consumes propellant. A microgravity environment provides an extraordinary laboratory where phenomena and physical processes can be observed without the distortion experienced on Earth. Lack of Earth's deep gravity well in cislunar space helps scientists to understand the growth of proteins as near-perfect crystals. Artist's illustration of plans for a new program to develop materials for building large structures in orbit and on the moon is shown in this picture. The absence of gravity effects provides new ways of isolating various mechanisms inherent in the evolution of tissue structure. This knowledge can be used for the production on Earth of improved artificial organs for medical purposes and for the design of bioreactors, recreating the normal conditions of growth of tissues and cells. Cells grown in space can also produce longer-lived cultures to help us understand the growth of tumors and give insight into how we might control this growth process. Illustration of satellites in cislunar space is shown in this picture. No launch vehicle constraint. A huge force is required to launch rockets into space. Engineers must consider three main things when designing rockets that can be launched into, such as the thrust, weight, and control. Launch vehicle variance constraint both the size and number of antennas that can be accommodated on a single satellite. Launching of launch vehicle in cislunar space will limit the constraints encountered on launching from the Earth. Platforms hosting payloads in cislunar space, serviced by robotic spacecraft, is shown in this picture. Cislunar space launch capability, the advent of human servicing and assembling in space, is necessitating the need to develop capability for launching rockets in cislunar space. Once humans can be able to live and work in space, it will be easy to build space systems on the moon and cislunar space. Cislunar mission concept is shown in this picture. Easy access of orbits beyond low Earth orbit is another cislunar space resonates. Presently, humans cannot routinely access orbits beyond low Earth orbit with people and machines to build and maintain satellites in space. All the propellant of a given launch vehicle are used to get people to LEO. At LEO, a new vehicle that had been fueled will be needed to reach various high orbits of cislunar space, which is home to current and future satellites. Development of lunar infrastructure concept is shown in this picture. The high orbits of cislunar space include Joseph-Louis orbit, the 36,000 kilometers high orbits at which communications and other global monitoring satellites orbit. At geosynchronous orbit, a single orbit takes 24 hours, the same time as the rotation period of Earth. Such satellites appear to hover over one spot on the ground, and the dish antenna pointed at their location in the sky never has to be moved to track it. Artist's illustration of moon exploration concept is shown in this picture. Space infrastructure is another cislunar space resonates. Developing infrastructure in cislunar space will enable more efficient transportation, communication, and utilization of resources. This includes fuel depots, communication satellites, and space stations that can serve as waypoints for deep space missions. Cislunar space region is shown in this picture. Space resources mining is another rationale behind exploring cislunar space. Space resources refer to any natural resource or material that is available in space, which can be extracted or utilized for various purposes. Space resource mining refers to the extraction of valuable resources from celestial bodies such as asteroids, comets, and the moon. The concept of mining space resources is presently receiving our attentions. Artist's illustration of a lunar orbital spacecraft at the moon is shown in this picture. Cislunar space is vital for space resources mining operations. It provides a staging area for missions targeting the moon and near-Earth asteroids. These celestial bodies hold a wealth of resources, including precious metals, water, and other volatiles, which can be utilized for in-space manufacturing, life support, and propulsion. The moon from lunar orbit with planet Earth rising over the horizon, taken on the Apollo 8 mission, is shown in this picture. Examples of various space resources are water. Water ice is found on the moon, asteroids, and other celestial bodies. It can be used for drinking, as fuel for rockets, and for growing plants in space. Minerals. There are various minerals such as iron, nickel, cobalt, and platinum, which are found in asteroids and on the moon that can be used for building and construction. Map of cislunar space between geostationary Earth orbit and moon orbit is shown in this picture. Examples of space resources also are helium-3, which is a rare isotope that could potentially be used as a fuel for nuclear fusion. Solar power is a renewable energy source which can be harnessed in space without any atmospheric interference. Oxygen can be used for life support and rocket fuel. Illustration of cislunar space is shown in this picture. With renewed interest in lunar exploration, cislunar space will play an important role in supporting missions to the moon. Establishing a lunar base and exploiting the moon's resources, such as water, ice, and valuable minerals, will require a robust cislunar infrastructure. The moon offers other material and energy resources needed to create new space-faring capability, including regolith aggregate, glass and ceramics, metals, and solar cell fabrication. Artist's illustration of the moon village concept is shown in this picture. National security is another reason behind interest in cislunar space exploration. Cislunar space is increasingly viewed as an essential strategic domain for national security. Establishing a presence in this region allows countries to protect their assets, maintain situational awareness, and demonstrate their technological capabilities. Artist's illustration of moon mining idea is shown in this picture. Developing infrastructure in cislunar space will enable more efficient transportation, communication, and utilization of resources. This includes fuel depots, communication satellites, and space stations that can serve as waypoints for deep space missions. Permanent presence on the moon. By establishing a permanent presence on the moon, a transcontinental railroad for cislunar space, a reusable, extensible, and maintainable transportation system will be created. Artist's illustration of Starship firing its engines while passing by the moon is shown in this picture. For more information, contact Astronautics for Exploit. You've been watching and listening to Cislunar Space Resonails for the next space exploration frontier, presented by Dr. Ayoshola Ogunele, with the focus points cislunar space and cislunar space resonails. Thank you.